So today we'll start CCNA Virtualization. So we all know about servers. We all know about servers. What is servers? That provides different services to end user, or we can say client. If we talk about vendors, we have Dell, we have HP, we have IBM, even we have Cisco. Cisco provides UCS, Unified Computing System. So first of all, we talk about server before virtualization. Server before virtualization. So how it was? Let us consider it is a server. It is a physical server, a dedicated hardware. So we have hardwares like CPU, RAM, storage, NIC, etc. Over the hardware, we have operating system. It could be Microsoft, it could be Linux. And above operating system, we have different applications. Like web server, email server, etc. So it is our traditional model. It is our traditional model. So we have some disadvantages. We have some disadvantages in this model. So let us discuss about those disadvantages. So in traditional model, one physical server is used, like for email, one for web, one for database. So we need more space. So our traditional model, what is our traditional model? For every application, we need a separate physical server. we can run multiple application in a single physical server. But if that physical server goes down, multiple application will go down. So that's why we used a dedicated physical server for each application. So what are the disadvantages? This is our model of traditional servers, and disadvantages are it is expensive, more space required for every physical server, more power is used, even the server hardware is underutilized. That means if you run a single application in a dedicated physical server, like you are running an email server in a dedicated physical server, actually you are using max to max 10 to 20% of server hardware. Rest 80 to 90% is unutilized. Rest 80 to 90% is unutilized. So this is the model which is used in before virtualization. So virtualization is introduced and we all move to that virtualization. So in virtualization, we have two different types mainly. Type 1 hypervisor and type 2 hypervisor. Type 1 hypervisor and type 2. First we will discuss about type 1 hypervisor. So this is our physical server. This is hardware. This is type 1 hypervisor. Here we have VMs. VM1, VM stands for virtual machine. VM2, VM3. and we have App OS, application operating system. So this is a type. So we can say for type 1 hypervisor, multiple operating system can run in a single physical server. Here we see there are 3 different operating system is running in this single physical server. This is a physical server. Next, we can say each instance of operating system is known as VM, that is virtual machine. In this physical server, we are running 3 different instances of operating system over this type 1 hypervisor, and each operating system is known as VM, VM1, VM2 and VM3. Now, what is the function of hypervisor? Hypervisor is used to manage and allocate hardware resources to each VM as per their need. That means, suppose you have 128 GB of RAM. This particular VM requires 16 GB. So type 1 hypervisor will allocate 16 GB RAM to this VM. Suppose this VM2 needs 32 GB. So type 1 hypervisor will allocate 32 GB of RAM to this VM2, and VM3 it requires suppose 8 GB. Type 1 hypervisor will allocate 8 GB of RAM to VM3. So the main function of hypervisor is to manage and allocate hardware resources. Suppose now the requirement of RAM for VM1 is increased. Now it requires 48 GB. So type 1 hypervisor will allocate some more RAM to VM1. This hypervisor is also known as VMM. What is VMM? Virtual Machine Monitor. Actually, it monitors all the virtual machines. It monitors all the VMs over it. Hypervisor which is on top of hardware is known as type 1 hypervisor. So what is type 1 hypervisor? The hypervisor which is top of hardware. Like, if you need example, VMware, ESXi, Microsoft, Hyper-V, etc. It is also known as bare metal hypervisor or native hypervisor. Actually, these are different terminologies used for type 1 hypervisor. We use this type of hypervisor is used in data centers. This type of hypervisor is used in data centers. So this is all about type 1 hypervisor. So now we'll discuss about type 2 hypervisor. Type 2 hypervisor. What is type 2 hypervisor? In type 2 hypervisor, this physical server is changed somehow, like above hardware. Now we have host OS, host operating system. It could be Linux, it could be Windows. Here we have some apps. We have some applications. For the end user. Now here we have type 2 hypervisor. Above type 2 hypervisor, we have VMs. It is called guest operating system. Above guest operating system, we have some different apps for our needs, and these are two VM1 and VM2. So this is the infrastructure of type 2 hypervisor. So type 2 hypervisor is it is a type of program on an OS like other computer program. Like you have Microsoft Office, you have GNS3, you have Packet Tracer. These are different computer programs. It is just same. So VMware Workstation, we all use it. Oracle VirtualBox, are the example. We all know about it. What is VMware Workstation? If we want to create an additional operating system in our machine, we then use VMware Workstation or Oracle VirtualBox. Next, OS running on hardware OS that we can say OS that directly running on hardware is called host OS. So this is the host OS. We have we have Windows 10 installed in our PC. So Windows 10 is the host OS because it is running directly on hardware, on top of hardware. And OS running in a VM is called guest OS. So inside these two VMs, we have two different operating system, like one is Linux, one is Windows 7. So these two OS is known as guest OS. It is also known as hosted hypervisor. It is also known as hosted hypervisor. But it is not used in data center, not used in data center. Mostly used in home or experimental environment. Home or experimental environment. So this is all about type 2 hypervisor based on our syllabus. There is lots of things about all of this. Now, what is the advantages of virtualization? We know disadvantages of that period when we don't use virtualization. Now, what is the advantages of this virtualization? So, we can run multiple operating systems on one physical server that properly utilize the system resources in VMs. So in earlier days we see that only 10 to 20% hardware resources are used and rest are unutilized. But if we run multiple operating system on one physical server, the most of the system resources will be used. The second advantage is we need fewer physical servers are needed that reduce the utilization of space. So in earlier days we have 20 physical servers. Now we have 3 physical servers. So it reduces the utilization of space. Obviously, power, cooling. So fewer physical servers are needed that reduce the utilization of space, power and cooling. Overall, that reduces the cost or expense. So this is second advantage. Easy to move any VM to any physical server. So there is no dependency on hardware. We can easily move one VM to another, one VM from one physical server to another physical server. So easy to save the entire VM to files to use in disaster situation. So we can save VMs in format of files. So in case of disaster situation, if the physical server goes down, we can use that file in another physical server immediately. So it reduces downtime. Downtime is reduced. You don't need too much time. You don't need too much time in disaster situation. Another major advantage is fault and security isolation at hardware level. Fault and security isolation we can get at hardware level. As well as enhanced performance with advanced resource control. Suppose a VM needs 8 GB more extra RAM. So hypervisor is used, which will allocate the additional hardware to that particular VM. So the performance is enhanced with advanced resource control. So these are some basic advantages of virtualization. Now the question arises, how these virtual machines are connected to our physical network. The last part of this series, of this video, how these virtual machines are connected to our physical network. So consider this diagram. In this physical server, suppose we have VM1, VM2 and VM3. So we have VM1, we have VM2 and we have VM3. All these VMs have virtual NIC. That is known as VNIC, virtual NIC. Actually, these are separate systems, separate virtual systems. These virtual VMs virtual NICs are connected to a virtual switch inside the physical server. This is called V switch. And you can create VLANs. Suppose VM1 is in VLAN 10, it is in VLAN 20, it is in VLAN 30. Now this switch is connected to, suppose you have two physical NIC. It is physical NIC of this physical server. This virtual switch is now connected to this two physical NIC using trunk link. This linker trunk, we know this linker trunk because multiple VLAN information will be carried through this link. Now these two physical NIC is connected, suppose, with two different physical switch. Physical switch 1 and physical switch 2, and this link is trunk link. So this is how VMs are connected with our physical network. So this is all about CCNA virtualization as per CCNA.